Hello. All right. So last night you guys watched a video that introduced solving radical equations. So what we're going to do is we're going to try some out here. Okay. The first one we're going to do together, and then I'm going to have you try some on your own. All right. Now we're going to just follow right off the directions here. The number one says to isolate the radical. What that means is we have to get the radical all by itself on one side of the equation. So see how we have this plus 11x that's outside the radical on the same side of the equation? First thing we want to do is we want to get rid of that. So I'm going to subtract 11x from both sides of the equation. Okay, so on the left-hand side, we're left with just the radical term. So we have the square root of x squared plus x minus 1. Okay, and then on the right-hand side of the equation, we're just going to combine our like terms. So 7x minus 11x would be negative 4x. And then I'm going to bring down the plus 3. Okay, so now once we have the radical by itself, what we want to do is we want to get rid of this square root. Okay, so let's think about what cancels off a square root. Well, a square, right? If you square a square root, it cancels it off. So that's why step 2 says square both sides of the equation. Okay, it says if a square root. If you have a cube root, you would cube both sides of the equation and so on. So here, we're going to take both sides of the equation. I'm just going to put both sides in parentheses, and we're going to square it. Okay, you're allowed to do that as long as you do it to both sides of the equation. All right, so let me just move this up a little. All right, now, like we said before, we know that a square and a square root cancel each other off. So we're left with, on the left-hand side, just what was underneath that radical, x squared plus x minus 1. Okay, and now on the right-hand side of the equation, if we have a binomial, right, two terms being squared, unfortunately, you can't just distribute the square inside the parenthesis. What it means is when something's squared, it means we have two of them. So we're going to take this and we're going to write it out twice. Okay, now if you look back up at the steps above, step number 3 says to solve. Okay, so all we're going to do is we're going to go through and we're going to solve this equation. All right, so let me give myself a little more room here. All right, so I'm going to just bring down the left-hand side for now. And on the right-hand side of the equation, we're just going to double distribute. So negative 4x times negative 4x is 16x squared. Negative 4x times 3 would be negative 12x. 3 times negative 4x is negative 12x. And 3 times 3 is 9. And remember, every single thing that I'm writing on this paper should go in your notes, okay? If I write it here, you want to write it in your packet. If for some reason you don't have your packet with you, you can do this on paper, but, you know, make sure you're copying everything down. All right, now we know whenever we have like squares involved in our equation, we want to get everything to one side of the equation, right? We want one side set equal to 0. And I'm going to actually move these 3 terms to the right because I want to, since this number in front of the x squared is bigger than this number in front of the x squared, I'm going to move everything to that side because I want to have a positive leading coefficient. So what I'm going to do is I'm going to subtract the x squared. I'll line it up under that x squared term. I'm going to subtract this x, and I'll line it up under these 2 x terms. And then I'm going to add the 1, okay, which I'll line up under the number on the right-hand side. All right, so on the left-hand side, right, everything cancels. So I'm left with 0. And then here I'm just going to combine my like terms. So 16x squared minus 1x squared would be positive 15x squared. Remember, I wanted that to be positive. That's why I wrote it this way. And then negative 12x, and negative 1x would combine to give me negative 25x. And then over here, 9 plus 1 is 10. All right, now I'm just looking ahead. And to make my life a little bit easier, I mean, see how I could factor out a 5 out of each of these terms? Now, because I have an equation instead of an expression, rather than factoring out the 5, I'm going to divide both sides of the equation by 5. Because remember, if it's an equation, whatever you do, whatever number, right, you don't want to ever divide by a variable, but because then you're eliminating some of your answers. But here, whatever number I decide to divide the left-hand side of the equation by, as long as I do it to the right, I'm good to go. All right, so that leaves me with 0 equals, and then 15 divided by 5 is 3, so 3x squared. And then negative 25 divided by 5 is negative 5, so minus 5x. And then positive 10 divided by 5 is positive 2. All right, so we're just going to keep going. We're just going to factor and keep this up. All right, let me give myself more room. So let me bring down the 0, right, because you always want to keep it in equation. And here, since we have a number other than 1 in front of our first term, we're going to have to do the rainbow. All right, so when we do the rainbow, we do not set up 2 sets of parentheses, right? We bring down the first term, we leave a big space, and we bring down the last term. And we want to come up with 2 numbers that multiply to 6 and add to -5. Okay, so -3 and -2. And because this middle term has an x, I have to put an x on each of these. All right, and now we're just going to group. So bring down my 0 equals, and out of the first 2 terms, I could pull out a 3x, which leaves me within parentheses x minus 1. Now out of the next 2 terms, I could either pull out a -2 or a +2. If I want to be left with a positive x and a -1, right, x minus 1, if I want to be left with this in parentheses, in order to do that, I'm actually going to have to pull out the -2. Okay, and when I do, that'll leave me with -2x divided by -2 is positive x, right? And then +2 divided by -2 is -1. All right, so that's awesome. So now that we know that this and this match, we know we're on the right track. All right, so we're going to group what's in front of those. So we're going to group together the 3x and the -2 as one of our factors. And then the x minus 1 is our other factor. All right, and then let's just make a t-chart and solve. So if I take the first factor and set that equal to 0 and solve, I would add 2 to both sides of the equation. So it gives me 3x equals 2. And then I'm going to divide by 3. All right, so I get x equals 2/3. Now remember, don't circle it right away because we have to check. Okay, with these, sometimes you wind up with extraneous roots. And then over here, we're going to, you can just look at this one and say x equals +1. All right, or if you want to write out x minus 1 equals 0 and add 1 to each side, you can. All right, so now we're going to basically plug these answers back in and see if they check. Now I'm going to just slide up my original problem. I'm going to kind of move this over. Now if you recall the 2 answers we got, I'm going to just put them over here. Was x equals 2/3 and x equals 1. Okay, so in order to check, I just took 2/3 and I stored it as x in my calculator. Remember, you type in 2 divided by 3, or you can use alpha y equals to make the fraction, and you hit stow x, okay? Then what I did was I plugged in the left-hand side of the equation into my calculator and hit enter, okay? And with x stored as 2/3, the left-hand side of the equation is equal to 23/3. And then I plugged in the right-hand side of the equation and hit enter. And look at that. With x stored as 2/3, the right-hand side of the equation is also equal to 23/3. Okay, so what that means is this 2/3 checks out. I'm going to circle that. Okay, now we have to do the same thing, but this time we're going to store x as 1. Okay, so again, I stored x as 1. I hit 1, store x, and I hit enter. Now, when I plugged in the left-hand side of the equation in the calculator, it gave me 12. When I plugged in the right-hand side of the equation in my calculator, it gave me 10. Look at that. These answers don't match up. So what that means is, even though I solved everything correctly, okay, this is an extraneous root. All right, it doesn't substitute back into the original equation. And make sure you always substitute it back into the original equation because, it may check back, into this step down here or this step up here. But you always want to check and see, does it check in the original equation? And this one doesn't. So you would cross this off and you could write out extraneous root. Sorry, that's an O right there, O-U. All right. Now, what I'd like you to do on your own is I'd like you to try out the next page, numbers 1 and 2, on your own. And then you can just, hit play on the video and see how you did. All right, so we're going to, first, step number 1, we're going to isolate the radical. So I need to get this -2 over to the other side of the equation by adding it. So that leaves me with x plus 2 on the left-hand side, and then equals, and on the right-hand side, we have isolated that radical. We got it by itself. Okay, now once we isolate the radical, we know that a square is what cancels off a square root. So I'm going to square the right-hand side of the equation. And if I do that to the right, I also have to do it to the left. Okay, so now on the left-hand side of the equation, if we have x plus 2 squared, right? The square means that we have 2 of those, so I'm going to take that and write it out twice. And on the right-hand side of the equation, the square and the square root cancel each other off, so I'm just left with the 3x plus 16. All right, we're up to step 3 already. Step 3 is to solve, so let's do it. X times x is x squared. X times 2 is 2x. 2 times x is 2x. And 2 times 2 is 4. And I'll bring down the equals 3x plus 16. Now, we know that because we have a square on our x, we're going to want to get one side of the equation set equal to 0. So I'm going to subtract the 3x. I'll line that up under my 2x terms. And I'm going to subtract 16. So I'll line that up under my number. All right, so on the right-hand side, everything cancels. On the left-hand side, I'm left with x squared. And then if I combine 2x, 2x, and negative 3x, that gives me a positive 1x. And then here, 4 minus 16 is negative 12. All right, this one's a little easier to factor than the last one because we have a 1 in front of our first term. All right, so what we have to do is we have to come up with 2 numbers that multiply to negative 12 and add to positive 1. All right, so that's going to be x plus 4 and then x minus 3. Okay, and then we're going to make our t-chart. So we wind up getting x equals negative 4 and x equals positive 3. Now remember, we don't circle them right away. We have to check them. And you can use the store button in your calculator, but you want to check and see if we have any extraneous roots. Okay, so I did it in my calculator. You don't have to do this in your calculator. You can just substitute it in and figure it out by hand. I mean, it's pretty straightforward. But if you want to do it in your calculator, okay, I first check the negative 4. I hit negative 4, store x. And then I plugged in the left-hand side of the equation, which is kind of pointless because it's just an x. And then I plugged in the right-hand side of the equation. And what you could see is that the left-hand side of the equation does not equal the right-hand side of the equation. So that means that this value of negative 4, x equals negative 4, doesn't check out. So this we're going to cross off, right? This is one of our extraneous roots. You're not always going to have an extraneous root, but sometimes you will, so you always have to check. And also it's good to check because you want to know if your other answer is correct. All right, so then here I did the same thing. I stored x as 3. I did 3, store x, and then I plugged in the left-hand side of the equation as well as the right-hand side of the equation, and look at that. The left-hand side of the equation and the right-hand side of the equation both equal the same value. They both equal 3. So this answer is our solution, x equals 3. All right, so now you could try out number 2 on your own. This one's a little harder because there's 2 radicals. So when that happens, you want to isolate one of the radicals and then square both sides of the equation and go from there. See how you did? And then you can hit play and compare your answers with mine. Okay, so first thing you want to do is you want to isolate one of the radicals. So I'm going to just get this first radical here by itself. I'm going to add radical x to both sides of the equation. Okay, so on the left-hand side of the equation, I'm left with the square root of x plus 4. And on the right-hand side of the equation, you have to leave them separate with an addition sign, right? You can't combine a 3 and a radical x. They're not like terms. So we're going to write that as 3 plus radical x. Now, since we've isolated this radical, we could now square both sides of the equation. Because although we're still going to have a radical on the right-hand side of the equation, doesn't a square and a square root cancel each other out? So at least we were able to get rid of one radical to start. Okay, so that leaves us with x plus 4 equals. And then here, I'm going to have to write this out twice and double distribute. Okay, so let me first bring down the x plus 4. And then I'll have 3 times 3 is 9. 3 times radical x is 3 radical x. Radical x times 3 is 3 radical x, right? You just put the number in front of the radical. And radical x times radical x, remember, if you're multiplying 2 numbers, 2 of the same numbers under the radical, it just drops the radical. Radical x times radical x is just x. Because think about it. Isn't radical x times radical x squared? Because we have 2 of them. Right? If you have 2 of them, you can write it with a square. And then doesn't a square and a square root cancel each other off? So this is equal to just x. Okay, so I'm going to bring down plus x. Okay, so now what we want to do is we want to try to get the radicals by themselves on one side of the equation. You want to get everything else over to the other side of the equation. So see how this 9 doesn't have a radical on it? I'm going to subtract it. I'm going to move it to the other side of the equation. Okay, I'm lining it up under the number. And then see how this x over here doesn't have a radical on it? I'm going to get rid of that as well. I'm going to subtract it. I'm going to move it to the other side of the equation. Okay, so now on the left-hand side, actually x minus x, those cancel. And 4 minus 9 is negative 5. And then let's see, on the right-hand side of the equation, we already canceled off the 9's and the x's. And these are like terms. We can combine them. 3 radical x plus 3 radical x is 6 radical x. Okay, now from here, you could do one of two things. You could jump right into squaring both sides of the equation if you want. Or, if you would like to, you could first get the radical x by itself, right? You could divide both sides by 6. So that would leave us with negative 5 over 6 equals, and these 6's cancel off, radical x. Now, if we want to get this x by itself, we want to get rid of the radical. And think about, doesn't a square root cancel off by squaring it? So let's square both sides of the equation. Okay, so I'm going to square the left-hand side, and I'm going to square the right-hand side. All right, so then over here, if you square negative 5, 6, well, a negative times a negative is a positive, and then 5 squared is 25, and 6 squared is 36. And on the right-hand side, a square and a square root cancel each other out, so it leaves us with x. Now, if you notice, I'm not circling this. I want to check and make sure that, you know, when I substitute in 25 over 36 in for x into this original equation, that it checks out and gives us 3. All right, so it actually kind of got cut off the screen. Sorry about that, but I took 25 over 36 and stored it as x and hit enter. And then what I did was I plugged in the left-hand side of the equation in my calculator and hit enter. Now, I didn't bother plugging in the right-hand side of the equation because the right-hand side of the equation is just 3. So if you look, this is a 3, and this is 4/3. The left-hand side of the equation is equal to 4/3, whereas the right-hand side of the equation is equal to 3. So these do not match up. So what that means is this, our only one solution, didn't work. So we have to cross it off. This problem actually has no solution. Okay, I'm going to write that out. No solution. Nothing, oops, sorry about that S, but nothing works in this equation. Okay, now some of you may be looking and being like, yeah, but no solution. Like, how do I know if I just did the problem wrong and that's why it's not checking out? So this is a good way to check. What I did was I went to y equals in my calculator. Okay, and I plugged the left-hand side of the equation into y1, and then I plugged the right-hand side of the equation into y2. Now, if they had a point, if they had a solution, the two graphs would have to intersect. Okay, now when I hit graph, this one right here was my first graph. This is the left-hand side of the equation, okay, radical x plus 4 minus radical x. And then this is the second graph, the right-hand side of the equation, okay, y equals 3. If you notice, they don't intersect. So there actually is no solution. So that's a way you could check. And, you know, you could check the other examples that we did by going to y1 and y2 and graphing and seeing, you know, what the x values are at the points of intersection. All right, what I'd like you to do now on your own is I'd like you to try out number 3 and 4. And I just want to point out, number 3 and 4 are multiple choice. Let me actually flip to that page. Hold on one sec. Okay, so number 3 and 4, they're multiple choice. If you have multiple choice, you know how your last step of solving a radical equation is to check? Okay, with multiple choice, there is no point in solving these equations by hand. Honestly, there's no point. Because if you have to check anyway, right, to see for extraneous roots, you might as well just jump right down to the 4th step, jump to the check. You're just going to take these answer choices and substitute them in and see what checks, right? So take the -6, plug it in for both of these x's, and see if it equals 1. If not, go on to the next answer choice. So all you're going to do is take your answer choices and plug them in and see what checks. All right, so I'd like, for the lab and regular classes, I'd like you to do numbers 3 and 4 on your own, and then check your answers with my work. For the accelerated classes, in addition to doing those, you're also going to do, on the next page, numbers 5 and 6. And then you can go on the answer key under the Unit 4 handouts, under radical equations, and you can check your answers with that. Okay, so in number 3, I looked at the first answer choice, and I stored x as -6 in my calculator. And then I just plugged in the left-hand side of the equation, okay, right here. And when I did, it did not give me 1. It actually gave me an error. And the reason it gave me an error is because if you take -6 and substitute it into this radical, you actually wind up with a negative under the radical. So choice 1 didn't work out, okay? So that one we can cross off. Okay, so then I tried out choice 2 now. I stored x as 2 in the calculator. I did 2 store x, and when I plugged in the left-hand side of the equation, look at that, it gave me 1, which equals the right-hand side of the equation. So it means choice 2 could be the answer, or let's look at choice 4. Choice 4 also has a 2 in it. So we also have to see if 22 checks. Now I'm going to tell you, choice 3 can't be the answer, because if we know that 2 is one of the solutions, it either has to be choice 2 or choice 4. All right, so then I took the 22 and stored it as x in my calculator, and when I plugged in this left-hand side of the equation, it gave me -1, not +1. So 22 doesn't check either, so this one is not our answer. So choice 2 would be the answer. Okay, so this one I'm not going to go into as much detail as in because it's the same as the last one, but basically I tried checking -8, +7, -7, +8, and 7 is the only one that checked. When I took 7 and stored it as x, when I plugged in the left-hand side of the equation and then the right-hand side of the equation, they both wound up giving me the same value. So 7 was the only value here that checked. By the way, if 7 didn't check, like if none of these values checked, you would pick choice 4, which means no solution. It's the empty set. Okay, just a reminder, if you're in the accelerated classes, you're now going to turn to the next page and do 5 and 6 on your own, and then you can check with the answer key on Google Classroom under Unit 4 handouts and go to answer keys.